tēnā koutou katoa. Welcome to Te Hongana, the Christchurch City Council Civic Office. It's a real pleasure to have you here tonight, and thank you very much for the Superhome movement and friends who are going to put this discussion on tonight around walls and how we can do that better and smarter. So thank you very much for coming out tonight. Really appreciate you being here. And again, a big thanks to the Superhome movement and friends for also offering this advice and guidance to you. We are in the Civic Office building. This is a Green Star 6 building. The plaques are on the walls over there. One of the greenest office buildings actually in New Zealand, which we're proud of, and we try and tell that story whenever we can. The toilets, of course, are just out the door and behind those, to the left, behind those wooden walls there. In the likely event that there's an earthquake, please drop, cover and hold. So cover your heads, because sometimes ceiling panels can fall from the sky. So cover your heads. We can leave, of course, out this door here, but we should wait for the earthquake to subside, because just on the outside of this building is a very tall glass building, right through there. So we don't want to rush out, don't be in a rush to get out there. When the earthquake stops, we can then go across towards the art gallery, and in front of the art gallery is where we'll gather to make sure that everyone's safe and sound. It's the same case for a fire. Obviously the alarm will signal. If you're out in the foyer there, some of the area is cordoned off by big smoke screens. They just drop from the ceiling. So you need to look to the ends of the building, at either end of the fire exits of the building, through that door and through the door at the far end as well. That's your way out, because the fire blankets will stop you getting out, or smoke screens will stop you getting out. I think that's probably enough from me. I'm again Tony Moore, City Council Sustainability Advisor, and it's a real pleasure to have you here. I'm sure someone's going to describe the evening for you. Is that right? Looking that way? You good? Okay. But anyway, the City Council is really supportive of what the Superhome movement is trying to do for New Zealand, to lift the quality of homes throughout New Zealand. We hear obviously very bad statistics for health and well-being associated with that housing, but also because we have some real climate challenges we need to meet as well. And the City Council right now is drafting its climate change strategy, looking at minimising our footprint. We have set a target for this city to be halving our emissions in 10 years, and then by 2045 to be carbon neutral as a city. That is in line with the IPCC, the International Intergovernmental Panel on Climate Change's advice. That is the level of change we need to see. So Christchurch is to be carbon neutral by 2045, and a big part of the solution, of course, is how we build our homes, both existing and new homes, and of course how we move. So we encourage you to bike, walk and cycle, or public transport around the city as well as build smarter homes. Anyway, that's enough from me. Thank you very much, and enjoy the evening. Over to Bob.
Thank you, Tony, and thank you to Christchurch City Council for your ongoing support for the Superhome movement and the Superhome tours and the use of this lovely venue. So, my name is Bob Burnett, for those of you who don't know me, but I see quite a few familiar faces, and because I'm getting older, I can't really see you with these glasses on, so you're just going to be a blur to me, and everything's really clear on the screen though. So it's always a challenge when there's a mixture of homeowners, industry people, designers, builders and so forth. So who's in the industry here? I can see a number of designers, so I know you guys. I can see one person with high vis on there, but is there anyone who's a builder here? Okay. Okay, so, and who are just interested homeowners here? And oh, that's good too. So, you know, it might get a little bit technical, so I can't see your eyes glazing over, but if you have any questions, just put your hand up, particularly the homeowners. But I'm only going to talk for 10 minutes, 15 minutes maybe, and I'm going to talk about super-insulated walls and panel systems, believe it or not, which I think is a big part of what makes a super home, you know, and the thermal envelope is by far the most important aspect of a home. Later this year we're doing a series of seminars throughout the country called Superstructure, and we're talking about the floor, the walls, the windows, the roof, the whole fabric of the building, the superstructure if you like. And we're really fortunate today to have Dan Saunders here, who has his Ecopanel hat on, and Dan is a very experienced builder who also is making structurally insulated panels and supplying CLT, which is imported and PLT, which is new, which is exciting, which he'll tell you about. So probably after, we're going to have a short break, and then we're going to hear from Richard from GIB about GIB's sustainability ethos and their story and what's happening there. And thank you to GIB for being a long-term supporter of the Superhome movement and sponsoring the tours as well. So yeah, so I'll just sorry about this next slide. It's a pretty manky slide, but it's just really to remind me what to talk about, so you don't really need to look at that. But so currently, Brands and Beacon Pathway are doing research into how much timber we use in our homes, and it's staggering. We use the ratio of timber is 30% to the rest of the wall, and it's approximately double what it should be. So it should be sort of in the range of 14 to 18%, maybe 16%. And why is that bad? Well, we want to try and eliminate thermal bridging, and anywhere where you've got timber, just for the lay people, it's nowhere near as good as having insulation, and that's called thermal bridging. That's one thing that we're trying to eliminate, yeah. So there's a number of ways to avoid that, and why do we do that? I don't know. Has anyone got any ideas? Why do we have so much timber in our houses? People from overseas come here and they say, "This is interesting, eh? There's so much timber in our houses." So
we're trying to store carbon in the building.
Yeah, that'd be a really good way to have carbon-negative buildings. Yeah, build it all out of solid timber, and yeah. But that's where CLT would be good. But anyway, there's sort of a trend worldwide to have insulation on the outside, or outulation, I've heard it called, instead of insulation. And that's an interesting way of doing things. And one of the projects that I'm going to show you actually does have the insulation on the outside. So to avoid build-up of timber in the walls, we really need to think about the makeup of the wall, the claddings. It could be that the sheet joins in the cladding is dictating there needs to be more studs, or there needs to be more framing timber to fix the claddings. One way around that is to have structural cavity battens, either 40mm or 45mm structural cavity battens. So then you're fixing the claddings into the batten instead of needing to fix it into the framing of the wall. So that makes complete sense. And the other thing is, which probably a lot of people are starting to become aware of, is we don't really need dwangs a lot of the time, unless they're required to fix things to the wall or for handrails or something like that. Dwangs are superfluous, particularly for fixing GIB. You don't need dwangs, and if you've got those structural cavity battens on the outside, you don't need dwangs either. And you can fill the whole wall with insulation. And I don't really understand it, because insulation's cheaper than timber. You'd think that they'd work out that you could save some money by having more insulation and less timber, but it doesn't seem to be happening. Rigid air barriers also make the house more structurally, provide better structural bracing. So yeah, another reason that we overdo the timber. I'm sure not everybody's using rigid air barriers, but it's sort of our go-to method. And that helps too. So, Superhome movement, most people have probably seen this house because it's been sort of widely publicised, but this was the first Superhome 4.5 years ago, and this house had not two different walls. It had the GIBFix framing system, which is really good, and I thought, well, this will just be the new normal way of doing timber framing, because like I said, it's got less timber, more insulation. If you look at these drawings here on the left, the red is the amount of insulation. Your typical wall is the top one. You've got 3 studs at the corners, 3 studs at the internal junctions to the external walls, and the one at the bottom is GIBFix. So most of you guys are probably aware of this, because you're sort of at the leading edge. But not many people are doing this, and I think it's a no-brainer because it's cheaper, it's better, it's more thermally efficient. It's really easy, and it's really easy for the builders. And GIBFix like it because it provides a opportunity to get a better finish and avoid any popping of fixings and cracking and imperfections and that sort of thing as well. So the first thing we think about is thicker walls to get more insulation into the wall, and this is what we were doing back when we did the first 10-star home. Now we've moved on from that. We're doing Ecopanel, where we've got a services cavity, we've got an insulated cavity, but Dan will talk about that later. You know, you could do a double stud wall, you could do I-beam sort of walls, you could do a T-stud. There's lots of things you could do, but I'm just talking about timber framing. And with our 10-star home, we wanted to just show something that's sort of not too different from traditional, but the next stage on from that, which is easy for people to adopt, and it's an affordable but modest size home, which is high performance. So when we built that, we had some fun, and I'm on the wrong angle there, but I ran around and I took all the dwangs out, because nowadays we just say we don't want the dwangs, and we get them to deliver the frames without the dwangs. And yeah, so you can notice the green, that's a rigid air barrier. So we're using a different product now for the rigid air barrier, but yeah, so get rid of the timber, fill it up with insulation. So this drawing basically I've said SuperWALL there, but this is basically sort of trying to do a build-up on site of what Ecopanel is. And so you've got an airtight insulated cavity with the airtightness membrane and the high performance wrap on the outside. You've got plywood. Dan will describe this in detail. But we quickly came to the conclusion that you might as well build it in a factory, and where it's all dry and clean, and then take it to site, and it's going to go a lot quicker. So this was the first house that we did with that method, using the Ecopanel method, and that was what it looked like 2.5 days after the slab going down. So I think the slab went down on Saturday, and Tuesday the truck started arriving with the panels and the CLT on the roof as well. And then by Thursday, I think, Michael, that was you Thursday lunchtime, I think, you cracked a beer and
I was in
you're
Germany.
finished?
I was in Germany on holiday.
Oh, were you? Okay. Yeah, anyway, so the insulation goes on top of the cross-laminated timber panel. So, sorry I'm using too many acronyms probably. But yeah, you've got this beautiful feel of a really sort of uplifting, light-filled space with a wooden ceiling and insulation on the outside, like what I was talking about before. That's really where you want the insulation. And then this is another project where we did Ecopanel, but this was a tiny site, and this one here we actually used 90mm structural insulated cavity and the 45mm services cavity, because it was a 280 square metre site, and we fitted a 4-bedroom, 3-bathroom house in there. So that also had a CLT floor, which was interesting because it was ridiculously soft ground. It was like porridge, and rather than dig out a hole a couple of metres of ground and put in engineered fill and then put in lots of concrete and reinforcing, we did a triple T raft, which is basically just what it sounds like. It's just poles and then joining vertical poles, and then on top of that we had bearers and CLT panels, and then on top of that we had a small concrete topping with a heated floor. So we effectively got a suspended, fully insulated suspended slab using CLT. And that was a bit of a breakthrough, because before then we thought, well, we can't do thermal mass, we can't do a heated floor on soft ground, or cost effectively anyway, and so that worked really well. And the other factor with that, it needed to be 900 above the ground because it was a flood management area. So other sites where you have that sort of constraint, it's good to have a suspended floor.
Quick question with flood. Is that in general 900 or can it be 600?
Oh, it varies
all
all
over
around
town.
town. We've done one where it had to be 1300 above the ground down in Darlington. So this house here is quite different because this is entirely made out of CLT, and except with a slab, and there's an intermediate floor that's similar to what I was describing with CLT and concrete, but this house has CLT walls and roof, and this house has external insulation, which is wood fibre. And I was talking, this is Julie Villard's house, who's the eco-design advisor here at the council. She apologises for not being here, but she might come along later. But so I can talk about her house while she's not here, without her hearing. So she tells me this house is carbon negative. So it's all the carbon sequestering materials in this house make it carbon negative. So I said, that's cool. I want to learn more about that. The wood fibre, I'm looking forward to the day when that's available, manufactured in New Zealand. It's imported at the moment, but it makes a lot of sense having the insulation on the outside and using a natural product rather than a petrochemical foam. And I think we should stop making things out of distilled dinosaurs. Anyway, I'll keep moving, and I'll probably just hand over to Dan now, and then probably at the end of the night I'm going to tell you a little bit more about the amazing things that we've got planned this year with the Superhome movement and our sort of year of events that we've got organised. So I think, we're there. Thanks, Dan.
Sure. Oh, there we go, look at that. So welcome along tonight, hey guys. Good to see you all here. So basically, Ecopanel is exactly what Bob's described it as. It's a prefabricated wall panel. We make it in a factory in controlled conditions. So the timber that comes to site, to our factory, stays dry, goes to site dry, and doesn't have the chance to get rained on and then dry out, then rained on, and dry out, as you'd see in most subdivisions around the place. So just going back to what the picture we see here is, this is what the minimum is, the minimum building code. It allows for services to be installed within the framing and the exterior wall. As you can see there, the wires and the pipes are all put in, and then the insulation's been installed after the fact, and you can see what happens over time, or may not even been installed properly. So we also see there, as Bob was talking about, the need for dwangs in the exterior wall. As you can see there, if those dwangs were emitted, there will be a lot more insulation running floor to ceiling, so that it helps in that thermal envelope. With the Ecopanel, we have an airtight wrap, so that's stapled to the framing as you see it, as you would see it there, and with the cavity service pattern on there, which with those wires and the pipes run there, and then we insulate that again. So it's as Bob said, it's a no-brainer. We shouldn't be building like that. One of the worst things that we can say in the building industry is that's how I've always done it. So we need to evolve, and the health of New Zealand really needs to get up to the plate. Really, well, it's not the health, but the building industry needs to get up to health, because I'll go back a bit. The building industry needs to get up to what we're doing in high performance building to create better health for the end user. So it's moving along there. So with Ecopanel, as I said before, it's built in the factory. It's fast, it's precise, and we'll see if I can find a video. Oops. So this house, oops, come on, And we actually had to slow this down because the guys were moving too fast.
Go back from the beginning, will you?
Yeah, right. If I can find the mouse. Where's the mouse gone?
It's over there.
Oh. Sorry about my technical abilities.
Yeah, I'm gonna try.
Oh. So this was day 2 of this particular build. It was on Redcliff's Hill. We have a split level, five levels on this home. We got it weather tight in 5 days. 4 days, sorry. So that was ready for roof, and I think that was sort of towards the middle of the year. Okay. So the weather was still a bit cagey, I suppose, for rain. So as you can see there, the speed on site is of great advantage for keeping the frames dry. The frames themselves are cost neutral if you're building the same thing on site materials. Where you get the benefit is in the scaffolding hire, the labour on site. To do that particular house again, if you're building it on site, would take you about 10 to 12 weeks. Imagining moving up a sheet of ply, up the scaffolding, nailing it off, coming down and get another one. So everything's done on site. We have minimal wastage, and the fact that we've got no dwangs or nogs, having insulation running full height creates the ideal thermal envelope. I might hopefully not let that go away.
Just click. Should click.
Sorry. So just use the wheel.
Yeah.
Yeah. Oh. Go back. So just moving on to what Bob was referring to as CLT, cross-laminated timber. This is a product we bring in from Austria. The company we researched a lot, and they produce more energy than what they use within their the way they do things. They're 100% recyclable, so everything they produce on site to make these panels doesn't go to waste. So it even comes out as pellets for, say, pallet fire. That's the extent that they go to. So they're a family-owned business. So we're really, it's a good thing for us to be involved with companies like that.
Biggest glulam manufacturer in the world.
What's that?
Biggest glulam manufacturer in the world.
Okay. So the CLT, as you can see the top one there, the CLT. So it's cross-laminated timber. It can span. It's good spanning capabilities both ways for roofs and floors. And then the bottom one, glulam, which is GLT, or parallel laminated timber, is very similar to that, but it only really spans one way. So if you imagine the CLT up the top, flipping it on its edge, it has great spanning capabilities, and it's a bit cheaper than CLT. So depending on what sort of situation you're using, it's a great option. So we've got some samples over there too. So if you want to have a look at those and come up with some questions, and then I'm more than happy to answer that. So we'll just come back to this one. Jen will just jump in and say a few words.
Hi, I'm Jennifer, and I'm one of the brains trust in Ecopanel, and I'm also involved in
Can't
the
you tell?
movement. So I guess when we took on Ecopanel, we were really thinking about why we needed to do this. Why is it important that we took this on? And one of the big key things for us was that we didn't want to use petrochemicals as much as possible. We didn't want to use polystyrene in our structural insulated panels. We wanted something that was more efficient, but we're having a hard time meeting that compromise. So that's where Ecopanel comes in. It's based on standard timber framing, but it's improved. So we're making it here in New Zealand, which is a really important point of difference for our panels. The other exciting thing about it is that they're bespoke panels, so we can make them according to different requirements, like Passive House, for example. We can make a panel to Passive House requirements. We can make them to Superhome requirements. We can make them architecturally designed and the systems in there to meet the living building challenge. That's a really important component, I think, to panels in New Zealand, because we have a varied diversity of needs around that. Some of the aims, though, that we have is that we're trying to achieve sustainability and in addition to energy efficiency. And that can sometimes be at odds when you're dealing with polystyrene and petrochemicals. They're very good insulators, but what happens at the end of the life cycle? And that's something that we're really considering with Ecopanel is, what does that life cycle look like? So we are challenging ourselves at the moment to think about the living product challenge, which just means we're thinking about these products and we're focusing our aims. And I think we all need to be thinking about that when we're thinking about building materials and in particular structural insulated panels where we're considering petrochemicals and polystyrenes and EPS that might actually be a burden on future generations when that house comes down. So we're thinking about regenerative materials, which is not just compostable materials, but how are we actually going to contribute to our communities and our environment and not be a burden on them. So that whole carbon sequestering with the CLT and the timber, that's an important component of this, but we also want to think about how are these products made and where do they end up in 200 years' time when the house comes down? Will the house be able to stand past 25 years? Will it be able to stand for 200 years? We need to be thinking about that when we're creating our products. So that's really, I think, how Ecopanel is different from a lot of other panels. It's based on standard framing, but it actually has a point of difference. So we're actually working on a declare label for Ecopanel, and technically we should be able to achieve that because all of the products that we use are red list free, and that means that we don't have the toxins that are on the red list, which are the list of all the building products which are the worst in our environment and to the health of the people. So all of the products that we have are red list certified, red list free certified. The other thing about declare is it's a voluntary declaration of the ingredients of our product, and that's so important. We are really supporting this initiative about making it transparent to the consumer about what's in these products. So we are freely telling people what's in our product, what's in our panels. We use timber and wool insulation sourced from New Zealand. We're supporting our local communities that way. We use insulation, glass wool insulation, and Worth nails and bolts, which are sourced from companies that are red list free and also are contributing to the environment. We just even today are contacting ProClima. They have red list free products, and we were asking them again, what do you do about composting your tape? We're challenging producers to step forward and have some product stewardship. Our products are all red list free, and our life expectancy is really a guess. We hope it will stand for hundreds of years. We expect that with the products that we have, that they're durable and watertight, they shouldn't be rotting, and we expect it between 1 and 100 years. The end of life for these, the wraps and insulation are 100% recyclable now and into the future. The bolts and timber is salvageable and reusable. And at the moment, as far as we know, the tapes go to landfill, but we're pressuring ProClima to see if we can step up and get some recycling. So these are important things, I think, for us to be considering as an industry about how we're going forward with our building materials. And sometimes it does mean that the cost of products is a smidgen higher than it would normally be. But I think if you're building a house, you're thinking about something that should outlive you. So it's really a pressure that we all should bear, I think. So yeah, that's us and declare and the products that are behind that. So Dan, did you want to talk about the structure of the wall or anything else?
I'll just run up here. Bit hard to see from there, I know, but if you've had a wee look before, the wall's basically made up. We use Nelson Pine LVL as the framework. We can do 90, 140, 200 I-beams as well. There are, as Bob said, that there is no dwangs. The structure is made up of the plywood on the outside, 9mm ply, or we use an OSB board as well. There we use, on the exterior, we use a 45mm structural batten running horizontally that holds the studs in place, and again the surface cavity on the inside does the same thing also. The insulation runs uninterrupted, full height from bottom plate to top plate. And the walls, the internal external corners, we use the GIB stud saver system. So there's 2 studs in a corner instead of 3 or 4, and empty spaces of uninsulated wall framing. So the exterior vapor permeable membrane we use is Proclime Extazana. That allows moisture to pass through, moisture vapor. And on the inside we have an airtight, another Proclimer product, Proclimer Intello, which is an airtight membrane. So when we're doing pressure tests, air pressure blower door tests on the house prior to lining, we make sure that's all taped up. So we're aiming to achieve 0.6 as a minimum air changes per hour, but depending on the design and aluminium exterior window joinery and stuff like that, it can change. Service cavity, again, that's where we run our pipes and wires. This is on the exterior wall, so the photo I showed earlier was of an exterior wall where the plumber's gone in, electrician's gone in, then we jam our insulation around it. This service cavity on the outside obviously steers us away from those problems, and then once those services have gone through, we then put another layer of insulation in there as well before the lining of your choice goes on. So say for a 90mm wall, we can get up to an R5 in value with just the insulation alone, with the 90mm insulation in the 45, and obviously as it goes up, you're getting more.
What's code for what would normally be on a wall?
I think depending on where you are in New Zealand, but in Christchurch, I believe it's 2.6.
No, it's up
2.
2.
Sorry?
2.
Only 2. How miserable. So I mean, I don't look at the code because we don't do that, and I refuse to do that. I've turned down many a job where developers have asked me to build units, and they said we want it cheap as possible, code minimum, and I've just walked away because I'm not putting my name to something like that where it puts clients and end users at health risks. So I've seen what code minimum houses do, especially with non-thermally broken aluminium and double glazing. We've got double glazing, what do you do? It doesn't change anything, it's still a hole in the wall and it still creates moisture, so that's one of those things that we're very passionate about, is building well above code. So,
Regards to LVL, can you explain why you chose an LVL over just standard timber? Because LVL obviously has got glues in it.
yeah. Well, the glues.
The green side of things.
Yeah. So we use the LVL because it's structurally more sound. With the treatments, the Azotec in it, it's a lot less harmful as well. I mean, yes, there are glues. We haven't got a utopia as far as a recyclable panel yet, but we are striving to, reduce that as much as we can. As far as, like, say, example, the exterior structural cavity batten, where most structural cavity battens are CCA treated, we're moving towards MCA, which is a lot more, it's better for the health anyway. Can't be any worse than CCA, so that's what we're doing as far as that goes.
So
Running
thanks,
out of
Dan. Yeah, so we are going to have questions at the end. We might even sort of set up a little bit of a panel discussion and at the end with for 10 minutes, 15 minutes. Probably now I'll invite you guys to have another drink and have something to eat, and then we'll hear from Richard from GIB. Thank you very much.